We're doing this predicted paper 6 for June 2025. It is just a best guess paper. There's no guarantee that anything on this paper is going to come up in your next exam. However, these are the topics that haven't yet been covered in papers 4 and 5. It is also a calculator paper. Apologies if you got the early version that said do not use a calculator. It will be a calculator paper, guys, so you're allowed to use it. Let's do this. Question 1, we've got a bog standard right angle triangle and we're asked to find angle B, A, C. So from B to A to C, the letter in the middle is the angle you're looking for. This is just plain old trigonometry. There has been some cosine rule. There has been some Pythagoras, but I've not seen plain old trigonometry yet, right angle trig. So that's the opposite. The longest side is the hypotenuse. This is the adjacent. This is an opposite adjacent question. So we're going to write so, ka, toa, and opposite adjacent is right there. It's a tangent question. So we'll write tan theta equals opposite over adjacent. Put the numbers in. We've got 37 over 20. And I'm going to bash that into a calculator. And that comes out at 1.85. We grab his calculator. We press shift, tan, equals. And that's going to turn it into the actual angle. And we get 61.6 degrees. Question 2, we've got a cuboid measuring 6 by 8 by 15. So let's quickly sketch that out. Cuboid, just like that. And it's going to be 6 by 8 by 15. It's got the same volume as a different cube. So let's do volume first. Volume is just going to be those three things multiplied together. 6 times 8 times 15. Excuse me. And again, this is calculator paper. And we get 720 centimeters cubed. It talks about this cube that's got the same volume. Well, a cube is your bog standard cube like that. And we know that the volume is 720. Thing about a cube, all these sides are the same length. So what we know is x times x times x equals 720, or x cubed equals 720. What we can do is find the side length x just by finding the cube root of 720. So I'm going to bash that into a calculator. And we get 8.96 blah blah blah. Leave that in your calculator, because then the question talks about surface area. Now surface area is the area of all these faces that you can see. So I'm just going to do one first. I'm just going to look at that front one and say, well, if I now know that this is 8.96 and this is 8.96, then I'm just going to do that times itself. All I'm going to do is grab my calculator and press the x squared button. And that's going to square this 8.96 thing that's waiting for me in my calculator. And I've run out of space, so I'll just write it up here. The area of that one face is 80.33, blah, blah, blah. Now be careful, I want total surface area. There are 6 faces, so all I'm going to do now is hit times 6, and that's going to be my final answer. That will be the final surface area. It comes out at 481.99. 3 significant figures, 482. Question 3, we've got a brick, and we've got the measurements of that brick. So I'm just going to quickly sketch it out. And it says it's 21.5 by 10.3 by 6.5, correct to 1 decimal place. Big alarm, this is a bounds question. The minute you've got some numbers that have been rounded, you're probably looking at a bounds question. I'm just going to sketch this in as the length, 21.5, because the next part of this question says these bricks are being placed end to end. So I'm not actually bothered about the other dimensions. I'm laying these out in a line, end to end, like you would if you were building a wall. What we need to do on any bounds question is do our bounds first. Don't do any maths until you've worked out the upper and lower bound. So we know this measurement is 21.5. It's been rounded to 1 decimal place, so that needs to go up by 1 to 21.6, and then come down by 1 to 21.4. And the numbers I'm interested in is this and this. This is your lower bound, and this is your upper bound. Now what we're saying is these bricks are going end to end, and they will definitely reach over 1 kilometre. So what I'm going to do is use the lower bound and see if that works, because if it works for the lower bound, the smallest answer, it will definitely work for the upper bound, a bigger number. So I'm only interested in this 21.45. I'm going to multiply that by 4663. Now that comes out at 100,021.35. Now that is centimetres, because that's what we started with the brick. This guy is saying that it will reach over 1 kilometre. So all I've got to do now is change these centimetres into kilometres. Well, centimetres to metres is dividing by 100. And that comes out at 1000.2135. And then if I want to go to kilometres, I'm going to divide by 1000. And that's 1.0002. And that is now kilometres. To show that Jocelyn's statement is correct, you can just put a big arrow to that answer and say bigger than 1. Part B starts talking about weight, and again, it's correct to 1 decimal place. So we've got some rounding. This is a bounds question still. We know that the brick is 2.8 kilograms, 1 decimal place, so go up again to 2.9, down to 2.7. And I'm interested in these two central numbers. So I'm just going to write them both down. The lower bound is 2.75 and the upper bound is 2.85, just midway between those two that are on as number line. Now when we read the rest of this question, we've got to be careful. A lorry can carry 20 tonnes. Well, 20 tonnes, if we times that by 1,000 to start with, that's going to change into kilograms. So we've got 20,000 kilograms. This is my lower bound for the brick in kilograms, and this is my upper bound for the brick in kilograms. And if I want to know how many bricks, it's going to be a division. I'm going to take what the lorry can carry divided by what a brick weighs. If I want the maximum amount of bricks, then I've got to start with my 20,000. And if I want the biggest possible answer, I need to divide by the smallest possible number. Okay, so I'm going to divide by 2.75. And again, I'm going to whack that into a calculator. And we get 7,272 bricks. It is point something, but I want the maximum, and you can't carry 0.7 of a brick. If you did 20,000 divided by this, because you're dividing by a bigger number, I promise you, you'll get a smaller answer than this, and we want the maximum number of bricks we can carry. And then the final part says, why might this not be possible to achieve? Why might we not get 7,272 bricks in the van? They just might not fit. Think about packing bricks into a van. They've got to go end to end. There's got to be no gaps between them. There's got to be a perfect size van to fit the amount of bricks. You might not get that amount of bricks in there. It's just not possible, really. Question 4, we've got my mate Alfez built a model of a lorry using this scale, 1 to 72. And what that means is, in his little model of this lorry, there's the lorry, there's the cab, I should say, and there's the trailer. In real life, every 1 centimetre on his model is the same as 72 centimetres in real life, and that'll be true. What we can say is that the length scale factor is just times 72. Quite simply, if his model is 1 centimetre long, the real lorry will be 72 centimetres long. Okay, so however long his lorry is, we're going to multiply by 72, and that's the length of the real lorry. When you've got a length scale factor, it's very tempting to use that for area and volume, but you can't do that. Okay, these scale factors actually multiply up. The area scale factor will not be times 72, it'll be times 72 squared, because it's an area question now. And likewise, a volume scale factor will not be times 72, but it'll be times 72 cubed, because it becomes a volume question. So what we've got to work with here is the volume scale factor, because the second line of this question says the trailer in real life is 90 metres cubed. What we need to do is take our 90 and divide it by this 72 cubed. All right, if the real life trailer is 90 metres cubed, we're coming down to a smaller version. That's why we're dividing and not multiplying. Again, I'm going to bash this on a calculator. And no surprise, you get a really small number, 2.4 times 10 to the minus 4 metres cubed. And that is correct, but this question says we want an answer in centimetres cubed. Makes sense because it's a tiny model. Why would we be working in metres cubed? So we've got to go from metres cubed to centimetres cubed. Well, metres to centimetres is times 100. But that's just working in length units. Because we're working in volume units, we need to not only do it once, twice, 3 times. We're working in cubic units, we effectively need to times by 100 cubed. And that will convert to centimetres cubed. And we get a much nicer answer of 241. There's your final answer. Copy of this question, my mate Alf is now painting his lorry and he's got 8 colours to choose from. And he's going to be a bit of a pain. He's going to paint the cab in one colour, the trailer a different colour, and then he's going to put his name on it and that's going to be a different colour again. So he's going to start with 8 colours to choose from. Then for the trailer, he's only got 7 colours left because he wants a different colour. And then for his name, he's only got 6 colours left because he wants a different colour again. Combinations, how many of them? You just times these things together. So I'm going to do 8 times 7 times 6. There are 336 possible combinations for this painting. Question 5, very similar to the lorry question. We just did all the combinations part of the lorry question. We've got a menu with 6 starters, 10 mains, and 7 desserts. And you're going to pick one of each of these to get a 3-course meal. We want to know how many different 3-course meals. We just multiply those together. So I'm going to do 6 times 10 times 7 on a calculator. There are 420 different 3-course meals you could choose. A 2-course meal is either a starter and a main. So there's 6 times 10 combinations there. It could be a starter and a dessert. So there are 6 times 7 combinations there. Or it could be a main and a dessert. So there are 10 times 7 combinations there. If we just work these through, we're going to get 60, 42, and 70. And I promise, if you add those together, you get the 172 that the question talks about. Question 6, we've got a table to complete for y equals x squared minus 4x plus 1. Don't be put off by this notation here. It's just saying your x goes from minus 1 up to 5. Just ignore it if you don't like it. It's just saying look at your table. That's what x values you're using. So this is calculator work. I'm just going to pick one number and show you how I'd put that into a calculator. So let's say x equals 2. In my calculator, I'm using brackets. I'm going to put 2 squared. That's the x squared bit. Then I'm going to take away 4 times 2. That's the 4x bit. And then I'm going to add 1. And that's how I'm putting it into a calculator. And we get minus 3. So minus 3 goes there. Just going to pause the video and I'll just fill in the rest of this table. And what you might see is some symmetry forming here with minus 3 in the middle. Minus 2, 1, 1, 6. I promise you that will be a 6. Quadratic curves are symmetrical about a certain point. So now we just need to plot this onto the graph below. And we're going to go across to minus 1 and up to 6. So across to minus 1 and up to 6 is there. We're going to go across to 0 and up to 1. Cross to 0 and up to 1. Cross to 1 down to minus 2. Cross to 1 down to minus 2. Cross to 2 down to minus 3. Cross to 2 down to minus 3. Cross to 3 down to minus 2. Cross to 4 up to 1. And we're getting a nice little smooth curve. Cross to 5 up to 6. Perfectly symmetrical. What we need to do is put a smooth curve through these. And this is going to be rough, but I'll try my best. Bottoms out there, missed one. You will lose a mark if you miss more than one. And then we need to go down, down, down. Oof, not bad at all. Okay, so we've gone through all the points. We have not got a flat bottom. That would cost marks. And we're definitely not doing this kind of thing. That would cost marks. Don't scribble. You've got to just do a nice, smooth line through the points. I tell you now, guys, you will know you've made a mistake if you get a point like this. And then people go, oh, it must be way. Garbage. All right, watch out for this negative number down here. Often people make a mistake with that one. Right, question 7, guys. We've got 7 rulers and 15 crayons coming to £7. Now, there's an issue here. This second line starts talking about pence. So straight away I've got inconsistent units. What I'm going to do is change that to pence. And I'm going to write myself a little equation. 7r plus 15c equals 700. Just noting that I'm working in pence here. This second line's also rough. It says a ruler costs 12p more than a crayon. So I think a ruler is a crayon plus 12, and this is already in pence, so I'm leaving it in pence there. That's quite hard to see that. A ruler is a crayon with 12 more added on. A ruler costs 12 more than a crayon. What we've got is simultaneous equations. Now I'm going to solve this the more advanced way first, because it's set up for that. If a ruler is c plus 12, then this ruler here is c plus 12. So I'm going to write 7r as 7 lots of c plus 12. And I've just substituted this c plus 12 into the first equation. And then we get plus 15c equals 700. Now we can start to work out this equation. 7 times c is 7c. 7 times 12 is 84, just expanding the brackets. Plus 15c is 700. Collect my c. 7c add 15c is 22c. 22c add 84 equals 700. Take 84 from both sides, we're nearly there. And we get 22c equals 616. Final step, divide by 22. And you'll get 1c, which equals 28 pence. Don't forget working in pence here. The minute you've got the cost of c, a crayon, we can go back up here and work out the cost of a ruler. A ruler is just a crayon plus 12. So a ruler is going to be 28, cost of a crayon, plus 12. And we can just double check. Yes, those are 12 different. And I promise you, if you did 7 40s and 15 28s, you'd get 700. There is a more standard way to solve simultaneous equations, and I'm just going to do this just in case it's the only version you've been shown. Some schools do just stick with an elimination method. So if we start with 7r plus 15c equals 700, and then this one, I'm just going to manipulate and say, well, if I take c from both sides, I end up with that. And then if I times all of this by 7, I end up with 7r minus 7c equals 84. And what am I doing here? Why am I doing this? Well, if I just rewrite this 7r plus 15c equals 700, and this one, forget that now, 7r minus 7c equals 84. This is a much more standard way of solving simultaneous equations, a much nicer way, you might argue, but here it wasn't set up to do this method. We'll now do a subtraction. 7r take 7r is gone. 15c take negative 7c will be 22c. And 700 take 84 is 616. You're going to get the same c is 28, and then you get the same r is 40. Just showing you that separate method, just in case this is the only method you've ever been shown. Some secondary schools do only stick with one method for solving simultaneous equations. Question 8, some pretty standard graph work. You just need to memorize these guys, what they look like. This one here, one of my favorites, that is y equals sine x. So that's that one done. This here, part A, that is your bog standard y equals 1 over x graph. And then down at the bottom, again, it's pretty standard. That there is y equals something to the power of x. Doesn't matter what. So you've got y equals 2 to the x there. Question 9, we've got a short recording, time taken to complete purchase on a website, and these are the results. So it took 6 people somewhere between 0 and 3 minutes. That's what we're looking at. It took 10 people somewhere between 3 and 6 minutes. We're asked to work out an estimate for the mean. First thing we're going to need is midpoints. We don't know how long these 6 people took, so we're going to assume they all took 1.5 minutes midway between those. And I'm going to do that for each grouping. So midway between 3 and 6 will be 4.5. Between 6 and 9 will be 7.5. Between 9 and 12 is 10.5. And between 12 and 15 is 13.5. If you're not sure how to get midpoints, guys, if it's not blaringly obvious, do 12, add 15, then divide by 2. Just half those things added together, and that's where the 13.5s come from. What do we need to do next? We need to multiply these midpoints by the number of customers. So this is all calculator work. I'm just going to start bashing these in now. So I've multiplied number of customers by midpoint in each row. What I'm going to do now is add all those numbers together. Get 1, 3, 3.5. I'm absolutely buzzing. I've done all that work. I'm close to the end. Beautiful, beautiful, beautiful. This is where most of you, or at least half of you, will make a mad mistake, because you're going to take your 3.5 and say, oh, there's 1, 2, 3, 4, 5 rows in this table. You're going to divide by 5. You're going to do all that work and lose the final answer mark. When you're calculating the mean, you add things together. That's what this step is being to achieve. And then you divide by how many people or how many things there are, not how many rows in a table. If you add all these numbers together, you will see there are 25 people. That is what you divide by. How many people, not how many rows. And you get 5.34 seconds. Makes sense between 0 and 15. If you're divided by 5, you're probably going to get an answer that's bigger than 15. How can your average be bigger than the maximum? It just can't happen. Part C says, why is it not possible to use the information in the table to calculate the exact mean? And it's just looking at these times here, and you can write something like, you've no idea what each person took in terms of time. They took between 12 and 15 minutes in that last row. Who knows what time they actually took, so we can't get the exact mean. Question 10, we've got a non-right angled triangle, and we're looking for the angle ACB, so we're looking for this angle. Now, this looks like it might be a sine rule question. The problem is, I've not really set up for a sine rule question. That side and angle is across from each other, but there's no side across from the angle I'm looking for. The only thing I've got is this, which is across from that angle. That's how a sine rule question works. You've got two sides and two angles, both across from each other. So this one here, I can't actually find. What I can do is find that one. What I'm going to do is scrub out these labels, because they could label it anything, and I'm always going to call the thing I'm looking for A. And if it's an angle, it's capital A. Across from capital A is little a. And then the other angle in my diagram I'm going to call B, and across from capital B is little b. This is now set up for the sine rule formula that you will be given in your formula sheet. Sine A over A equals sine B over B. We're then going to substitute in. Capital A is the thing I'm looking for. Sine A over little a is 12.4. Capital B is 63, so we get sine 63 over little b is 12.8. And then there's a one-step rearrangement. If I'm trying to find sine A, this 12.4 that I'm dividing by is going to come up here as a multiplication. So I'm going to get sine 63 over 12.8 multiplied by 12.4. So that's come onto a new line of work, and it should be here. I'm going to bash that into a calculator. Then I get 0.86 blah blah blah. Remember, that's the sine of the angle. So I'm going to hit shift sine equals. Then my angle comes out at 59.6 douche douche douche. Be careful. This is not the actual answer to the question. What I wanted was this angle, and what I've found is this one. So now there's one more step of working I need to do. The angle that I'm looking for, ACB, is going to be 180. Take away the answer that's sitting in my calculator, take away this 63 down here, and that is the answer that I'm actually looking for. And that comes out at 57.3 degrees. Question 11, bit of a monster of a bearings question. It's algebra and bearings, so that's a bit gross. It says the bearing of Bisham from Anton, so that's from here, is B. A bearing comes from north and is clockwise. So we're from Ampton, that's where we stood. That bearing there is B. It then says the bearing of Ampton from Bisham, so over here now, is 6B. And remember, bearings must go clockwise. There are only ever two bearings on this type of diagram, here and here. You have to go from north clockwise. What we want is the three-figure bearing of Ampton from Bisham. So we actually want this one. That's what we're looking for. Now, this is an algebra question, so there's some work we need to do first. Key bit of knowledge is this here has got to be 360 take away 6b. Just using the fact that angles around a point add to 360. There's another fact that we need to know. This same angle has to be 180 take away b. And that's using the fact that it's co-interior with my initial b. So this angle here has got two values. it's 360 take 6b, and it's also 180 take b, and it's the same angle, so they're the same as each other. What we've created is an equation with b's on both sides. I'm just going to write it down here so I've got a bit more space. 360 take 6b is 180 take b. Let's solve this by adding 6b to both sides. Get rid of your smallest b's. You're left with 360 equals 180. Add 5b. Let's take 180 from both sides, and we get 180 equals 5b. So b must be 180 divided by 5, which is 36 degrees. Remember, we're not actually looking for b, we're looking for this one, 6b. So I'm just going to do 36 multiplied by 6, and we get 216 degrees. Box plot question next. Some of these are pretty standard. This is actually quite a rough one. Let's plot what we know. We know the median is 31. This is a nice scale. It is just going up in ones. So my median, bang, there, 31. The highest score, that's nice. We like that. Highest score is 38. So again, just doing a little line at 38. I'm going to skip over the next one and look at the lower quartile. Lower quartile is standard for a box plot. We need that. 21, 2, 3, 4, right there. And then it gets a little bit annoying from this point because I'm not given the upper quartile. I'm given the interquartile range. So I need to figure out what the upper quartile is, just using a bit of knowledge. Well, the upper quartile take the lower quartile, which is 24, is the interquartile range, which is 11. Upper quartile take lower quartile is interquartile range. So something take 24 is 11, must be 35. 35 take 24 is 11. So my upper quartile sits at 35, which is there. And then I've got to do a similar thing, just trying to find a different colour, for the range. My range is my biggest take smallest. And I know that that comes to 23. What I've got is the biggest. What I've not got is the smallest. But I do know that biggest take smallest is 23. 38 take something is 23. That must be 15. That is my smallest number. So let's get that on there, which is about here. We're now just going to connect these all together. Remember, we've got a box in the middle, and these are just connected with lines like that. Part B, we've got Beth's box plot. We're now trying to work out the interquartile range from a box plot. Well, we just need the upper quartile, take away the lower quartile. Here is your upper quartile, so that's going to be 37. And then here is your lower quartile, which is 21. 37, take away 21 is 16. That is the interquartile range for Beth's score. Now part C, my pal Kareem says Beth was more consistent than LA because Beth had a lower median. Is he correct? Why or why not? Well, these guys are never correct. I feel a bit sad for them sometimes because they never get it right. He's saying consistent and then using the median. And that's not what we do. Okay, so I'm just going to write this down. Your consistency is given by your range or your interquartile range. A smaller interquartile range shows more consistent. The median just shows they were worse in this case because it was smaller. Okay, if you're going to talk about consistency, you need to say something like smaller interquartile range, more consistent. Question 13, we've got some pretty bog standard vector work to do. It says write vector A as a column vector. Well, here's vector A. To get from this point to this point, just following the arrow, we're going to go 1, 2, 3, 4 across and 2 down. So that's 4 to the right and 2 down. Remember, top number is left and right, with positive numbers being right, and bottom number is up and down. Positive numbers would be up, negative numbers are down there. We're going to do the same thing for vector B. Be careful, this here is 4b. So let's work that out first. To go from here to here, again, just following the arrow, we're going to go 1, 2, 3, 4 right, and 1, 2, 3, 4, 5, 6, 7, 8, 9 up. So we've got 4b is 4 right and 9 up. Bit rough, but we're going to do it anyway. If I want b, I'm just going to need to divide these by 4. So 4 divided by 4 is easy. That's 1. I need to do 9 divided by 4. This is a calculator paper, so I'm reaching for my calc, and I get 2.25. Bit rough that we've got a decimal in there, but it can happen. That is your vector b. There is no vector proof question on this paper, guys. Vector proofs have not come up. It's a rough one if it does. If you're aiming for a top grade, go and have a look at vector proofs, because I've not included it in this paper. 14, pie chart to draw. So we've got a table showing the results. They win, draw, lose, and then total. And it says complete a labelled pie chart showing this. There's several ways to do this. I don't know which one you'll be more comfortable with. The way I like to do it is to say, well, my total angle is 360 degrees. So I'm going to work out the angle for each of these. I'm going to do 18 divided by 40, 18 out of 40. And then I'm going to multiply by 360. Let's get rid of that. For the next line, I'm going to do 10 divided by 40. 10 out of 40 and multiply by 360. And then I'm going to do 12 out of 40. 12 divided by 40 times 360. And that's going to give me the angle needed for my pie chart. Some people find what one person is worth as a degree. It's just the same calculation, but in a different order. So I'm just going to work these out on a calculator. First one is 162 degrees. Second is 90 degrees. And third is 108 degrees. Just check that these three add up to 360. They do in this case, so we're all good. You're going to need a protractor. I'm going to just wing this because I'm doing it on my phone. So just watch what we've got here. Win is 100 no, tell you what, we'll do draw first because that's a nice 90 degrees. That's going to be straight across like that. You must show that that is draw, or put the angle in. Doesn't matter. You've got to show which one of these table values it is. Just put the word in there. That's your labelled pie chart. Lose is 108 degrees. Well, if 90 is straight down, I'll need about 10 more degrees. So somewhere like that. Please use a protractor for yours. You won't get marks if you just wing it like I'm winging it. And then finally, we've got win is 162 degrees. Just double check, measure your own sector what's left and make sure that's 162. It'll just let you know if you've made a mistake somewhere. There's your fully labelled pie chart, guys. And then part B, we've got 2 more pie charts for team B and C. And this guy down here is saying, C must have won more games. He's looking at the pie chart and saying they've got a bigger sector for win, so they must have won more games. Again, they're always wrong, these guys. Why might he be wrong? We don't know how many games are involved in these pie charts. If it's 20 games and 20 games, then he's right. But what if it's 20 games for Team C and 1,000 games for Team B? Then this would represent more wins altogether. So that's your key statement there. We don't know if these pie charts represent the same amount of games. Would probably be better. Question 15, there's a naughty bit of iteration to go at here, so we'll just see what we can do. We've got a cubic equation, and all we're told that there's a solution between 2 and 3. So what we need to do is substitute x equals 2 into this equation and see what answer comes out. And the answer we're aiming for the real solution is no. We're not going to get that. We're going to get something, and we'll see what comes out. So when x equals 2, we're going to do 2 cubed, take away 5 lots of 2, just replacing x with 2, and then take away 1. And this is all calculator work. And my calculator spits out -3. I'm going to now put x equals 3 into this same equation and see what happens. So I'm going to do 3 cubed, take away 5 lots of 3, and take away 1. And again, all on the calculator. And that comes out at 11. Now remember, my initial equation up here, look, was aiming for 0. My first answer came out at negative. My second answer came out at positive. 0, the real thing we're aiming for, sits between those. And if the real answer that I want sits between my answers, then the real x that I want sits between my x's. And that's enough. I've shown that the real x must be between 2 and 3 because the 0, the actual thing I wanted, sits between my 2 answers. You need to show that with a statement. Something like this gets full marks. That right there, showing a change of sign. You've gone from negative to positive, meaning that 0 is between that. You can shortcut it just by saying there's a change of sign in my answers, meaning negative to positive. So the real solution is between 2 and 3 that I started with. Question 16, some more iteration to do, but this is actually going on to do the iteration, not just showing a solution exists. What we've got is these horrible formula, but they're just showing you that the next thing that you're interested in is based on the current thing. That's all it's saying. Ignore those little ends if you don't like them. It's saying next thing is based on current thing. And my current thing is 2. Now, there's a way to do this on your calculator that'll take out all the pain for you. What you're going to do is press 2 and equals on a calculator. All right, whatever number they give you to start with, press it and press equals, and then that's just going to give a big giant 2 in your calculator. What we're going to do next is then program this formula into my calculator. So you're going to need to use all your calculator skills here. This is a fraction, so I'm going to hit the fraction button. And in the top, where my current thing is, wherever this xn appears, you're going to have to use the answer button. So it's not always on the top here. Wherever this xn is, you're going to put ans. Use your answer button on your calculator. Don't forget we're going to cube that. Down at the bottom of fraction is 30, so we're just programming the calculator at this point, and then we're going to hit plus, and then we're going to hit 2. Make sure this sits outside of the fraction. If you manage to do these steps, put 2 into your calculator, and then program your calculator to match this exactly, you can just start smashing the equals button. And if you press equals once, that'll give us x2. If you press equals again, that'll give us x3, and we could keep going, equals, 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 if we needed to. So I'm just going to do that now. And if we hit equals once, we get 2.2666. Hit equals again, no more work to do. 2.388. We could keep going, we don't need to. This is x2 and x3. If the question was solve the equation, you just keep smashing equals until your number stops changing. And here you have to do it about 10 times a bit up straight. Your actual solution comes out at 2.55. We don't need to go this far. That's just saying if you were asked to solve the equation, just keep going, keep pressing equals. And I've just realised that I've not included 4 decimal places, so I would lose a mark there because I didn't include 4 decimal places. So apologies for that. I'm not going to do the entire question again. I'll leave it up to you to figure that one out. Question 17, my mate Ling's throwing a dice and he does it 300 times, and then we've got all these results, all these frequencies. So 1 came up 42 times, etc, etc, etc. Relative frequency is just probability, but it's probability from an actual experiment or from an actual thing that's happened, not just working it out mathematically. So we're going to work out the probability of a 1 just by saying, well, we got 42 ones out of 300 attempts. Well, that's just 42 divided by 300, and that's where the decimal comes from, which is 0.14. We can keep doing that same calculation through the table. I'm going to do 27 divided by 300 and get 0.09. I'm going to do 60 divided by 300 and 3. Just a quick note, all these relative frequencies add up to 1. So if you get a table where there's just a missing value, you're just going to take all these away from 1. But I don't need to do that because I'm just going to do 75 divided by 300, which is 0.25. Part B says, my mate Ling thinks the dice may be biased. Why does the table support this opinion? Well, if you're throwing a normal dice, you should get the same amount of every number. That would be a fair dice, not biased. So just one more time, if your dice is not biased, we should get the same amount of each number. So I'm going to write that down. And then we move on and say, explain why the dice may in fact not be biased, why this could actually be a fair dice, even though we don't get the same amount of each number. And the reason is, he only threw 300 times, which is not a lot of times to throw a dice and say whether it's biased or not, believe it or not. If you threw this dice 1,000,000 times, or even 10 million times, then you might find that you get the same amount of each number. And in fact, the more times you do an experiment, the more likely you are to get the probabilities that you're meant to get from fair dices. Question 18, and I'm not going to lie guys, this one is going to be rough. We've got algebraic fractions that are being added together, and then we're going to solve this equation. So it's not just adding the fractions, it's adding the fractions and solving an equation. Again, there are several ways to do a question like this. I like to treat my algebraic fractions like my normal fractions. If I'm going to add them together, I need common denominators, and common denominators come from multiplying denominators together. So that's what I'm going to write. My first fraction becomes 5 over x plus 2 lots of x minus 3. But because I multiplied this x plus 2 by x minus 3, then the top thing needs multiplying by x minus 3. Let's do the second fraction. My common denominator is going to be the same. It's going to be x plus 2 lots of x minus 3, just multiplying denominators together. And the 3 on top also needs multiplying by x plus 2. All I've done on this left-hand fraction is multiply the bottom by x minus 3 and the top by x minus 3. This right-hand fraction, I've multiplied the bottom by x plus 2 and the top by x plus 2. I've not done anything to the 2 that's left on its own. Some teachers will be going crazy now saying that's not the nicest way to do it. That's the way I like to do it, and that's what I'm going to do with my video. Anyway, we've got algebraic fractions now with common denominators, meaning we can write them as a single fraction over that common denominator. So my denominator is x plus 2 lots of x minus 3. All I'm going to do is rewrite these top things. I get 5 lots of x minus 3 added to 3 lots of x plus 2. And again, I've not touched that thing on the right yet. That's just 2 still. Right, we're looking a bit there. It's still not great. This double bracket down here, I'm going to multiply both sides by it, and it's going to appear up there as a multiplication. So I'm going to do that now. What we get is 5 lots of x minus 3 plus 3 lots of x plus 2, just the numerator, equals 2 lots of x plus 2 lots of x minus 3. That denominator from above just came up as a giant multiplication. At this point, we've just got brackets to expand. So let's start smashing through that. 5 times x is 5x minus 15 plus 3x plus 6. This is a double bracket, so I'm just going to leave the 2 and expand this double bracket. And what you'll get is x squared. Use a grid to do this if you're not following what I'm doing, but you're going to get plus 2x minus 3x. Let's just show you where these are coming from. We've got x squared. We're going to get plus 2x minus 3x plus 2x minus 3x will be minus x. And then we've got to do 2 times minus 3, which is minus 6. Use a grid if you need help expanding that double bracket. That's a bit messy. I've got this final single bracket to expand. So we've got 5x minus 15 plus 3x plus 6 equals 2x squared minus 2x minus 12. Told you this was going to be rough. This is a quadratic. We've just got to tidy stuff up. We've got to make this solvable in terms of quadratics. So we've got 5x plus 3x. That's 8x. We've got minus 15 plus 6, which is minus 9. On the right-hand side, we've got 2x squared minus 2x minus 12. And what I want really is this quadratic to equal 0. If I'm going to solve it, I want it to equal 0. So let's take 8x from both sides and let's add 9 to both sides. And what you'll get is 0 equals, remember I'm taking 8x from both sides, minus 2x take 8x is minus 10x. And minus 12 add 9 is minus 3. I'll write it in a more standard way so you'll recognise it a bit better. 2x squared minus 10x minus 3 equals 0. That is now a quadratic that is solvable. We're not even finished. We've got to go on and solve this, and the big thing up here is saying solve this equation giving your answer to 1 decimal place. This is a quadratic formula question. So A is 2, B is minus 10, and C is minus 3. So let's write those down in a separate space. A equals 2, B equals minus 10, and C equals minus 3. All those are going into your quadratic formula. X equals minus B plus or minus the square root of B squared minus 4AC, all divided by 2A. Formulas provided on your formula sheet. You just need to know how to substitute in. Let's start doing that. X equals B is negative 10. So minus B becomes minus negative 10, which is positive 10. Be careful with that. Plus or minus the square root of B squared I can do. Negative 10 times negative 10 is 100. Take away, I'm going to try and work, no, I'm going to substitute this in. Take away 4 times A times C. C is minus 3. I'm going to divide all of that by 2A. 2 2's, I can do that bit, that's 4. Let's keep going. X equals 10 plus or minus. Let's work some of this out. 4 times 2 times minus 3 is minus 24. So this becomes 100. Take away minus 24, which is 100. Add 24, which is 124. So we get 10 plus or minus root 124 over 4. I'm going to have to jump right back to the top of the page for this. So back up here now. We can break off and get two solutions. X is 10 add root 124 divided by 4. Or X is 10 minus root 124 divided by 4. All calculator work. Your first X comes out at minus 0.3. I do want my answer to 1 decimal place. And your second value comes out at 5.3. Again, just rounding to 1 decimal place. This first solution comes actually from here. And this second solution comes from here. Guys, I'll be absolutely amazed if I did that 100% correct. Bent over a phone with a tiny little stylus pen in my hand. Please do comment if I've made any mistakes anywhere on that, and we'll get the right answer if so. Thank you very much. Question 19, we've got a speed time graph, and it's a nice one, nice straight lines, and we just ask for distance travelled. Well, the distance travelled from a speed time graph comes from the area underneath the graph. So I just need to work out the area of a triangle and a rectangle. This here is a triangle that's 15 across. It is 30 high. We're going to do base times height divided by 2, which comes out at 225 meters, because they're the units on the graph. This is even easier. This is just a rectangle. The base goes from 15 to 40, which is 25. And it's the same 30 high. So we're going to do 25 times 30 and get 750 meters. Final answer, because this is total distance travelled, is going to be 225 added to 750, which comes out at 975 meters. Part B, we've got a distance time graph, and it's a curved graph, so these are the worst ones. It says work out the average speed between 2 and 4 seconds. So we need to identify 2 seconds and 4 seconds, just looking at my bottom scale. What I'm going to do is turn this curve into a straight line. And then all you've got to do is work out the gradient of that straight line. I can't quite see where my point's meant to be, but we'll get a rough answer. Anyway, all I need to do is work out this measurement and divide it by this measurement. So using my scale, I'm just going to make this nice and say I'm going from 5 up to 24. So this will be 24, take away 5, which is 19. This one's nice. I can actually see that this is just 4 take 2. That distance there is 2. So my average speed will be the 19, the up measurement, divided by 2, the across measurement. And 19 divided by 2 is 9.5 meters per second, because they're the units on my graph. Now that there is the average speed between 2 points. Part 2 says what's the speed of the particle at 4 seconds at a single point. So what I'm going to do is just clear this graph off and start again. I'm not looking between 2 points now. I'm looking exactly at this point. And what I need to do is change this curved graph into a straight line at that point. You're going to draw a tangent. You're literally going to get your ruler, balance it on the graph. Mine's a bit naff. And draw a straight line that touches your curve but doesn't actually cross over it. And then what you've got to do is try and find the gradient of that straight line, which is always a bit harder, and we're all going to get different answers. So before you start crying saying, oh, that's a rubbish tangent, it is a rubbish tangent, but I'm working on a mobile phone here, and we're all going to get different answers anyway. I'm going to just try and find a nice-ish triangle that I can work out the gradient. Any triangle will do. I could have done one there, one there. As long as you can read these measurements, that's what matters. This up measurement goes from 10 to 43, so that's a distance of 33. And then this bottom measurement finishes at 6, starts at 2.8. From 2.8 to 6 is 3.2, and that's just how far across this measurement is. My estimate of the speed will be the up measurement, 33, divided by 3.2. Bash that into a calculator. And I get 10.3 meters per per second. We'll all get different answers for that as long as it's around 10, 10.5, somewhere in between that. It's close to this, so it looks decent. Question 20, we've got a prism, triangular faced, and we're just going to work out the volume to start with. So volume comes from the area of the cross section, which in this case is a triangle. So let's just sketch that out. 6 high, 10 across. We're going to do area is 6 times 10 divided by 2, base times height divided by 2, which is 30. And then we're going to multiply by this 11 for volume. So for volume, the area of the cross section multiplied by the length of the prism, and that would be 330 centimeters cubed. Part B says use trigonometry to show that FDC, so FDC, this angle labelled is 31 degrees. So again, I'm going to draw my triangle just so I can show the working. I'm looking for this angle here. This is 6, this is 10. It's telling me to use trig, that's the opposite. This longest side is the hypotenuse, so this is the adjacent. I'll write them all down. So, toa, opposite adjacent question. Tan theta equals opposite over adjacent, which equals 6 over 10, which is 0.6. Remember, that's not the angle, that's the tangent of the angle. So we grab his calculator and press shift, tan equals, and we get 31 degrees to the nearest degree. And part C says calculate the exact length of AF, which is this dotted line here, which is actually quite nice for 3D Pythagorean trig because it's the line that sits on the face, the top slopey bit of this prism. So it's not a bad one. It's certainly not as bad as it could be. What we're looking at is two right-angled triangles. This one here. So we can apply Pythagoras to it to find this. And then when we've got that, we've got our second right-angled triangle, which is here. And we can use the thing we're going to find the thing we're actually looking for. So we'll start on the green triangle. We've got A, B, and we're looking for C. We're going to just say A squared plus B squared equals C squared. Substitute. A is 6, B is 10, and we don't know what C is. 36 add 100 equals C squared. C must be the square root of 136, so I got a bit lazy there and skipped out a step, which comes out at 11.666. You know what, you shouldn't actually do that because we're going to use this again, so let's just leave it as root 136. This measurement here is root 136. Now I'm going to work on the red triangle because that's the thing I actually want, so let's just sketch that out again. This bottom measurement is 11. This side measurement is what I just found. That's root 136. Let's keep it exact so we don't lose accuracy marks. And then this is the thing I'm looking for. This is now my new A, B, and C. So we start again. A squared plus B squared equals C squared. 11 squared plus root 136 squared. Root 136 squared will just be 136. But I'll leave it in there so you can see. Equals C squared. What we get is 121 added to 136 equals C squared. C must be the square root of 257. And it says exact length, so that's it. I'm just going to leave it as root 257. It don't say simplify the third. If I put square root of 257 into a calculator, I get 16.03, blah, 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 blah. But that's not accurate. That's not exact, I should say. Just write it down in case you've gone that far. It wants the exact length. Leave it in third form. Question 21, we're looking at a circle, and we're looking at the tangent to the circle at the point -3, which is probably about there, 6. So let's just jot that there. And we want to know the gradient of the tangent at that point. The tangent is this line. It touches the circle but doesn't cross it. Well, what we can do is work out the gradient of this line, which just comes from these two measurements that have been given. So we know that the gradient, let's call it line A. So the gradient of A is just going to be my up measurement 6 divided by my across measurement -3. And 6 divided by -3 is -2. This line here is perpendicular, so it meets my line here at a right angle. So the gradient of that, it's a perpendicular gradient. They will multiply to make -1. So I'm going to do -1 divided by this gradient, and -1 divided by -2 is a half. Part B says find the equation of the tangent. Well, I already know the gradient. I've been told that. So my gradient m is a half. I also know a point that it goes through. It goes through the point -3, 6. So from that I can say x equals 3, -3, sorry, and y equals 6. So I've got an m, an x, and a y. If I substitute all those into y equals mx plus c, I'll find c, the unknown. So let's have a look. Y equals 6. M is a half, so we're going to do a half times x, which is -3, plus c. We get 6 equals a half times -3 is, I'll leave it in decimals, -1.5 plus c. Add 1.5 to both sides, you get c is 7.5. So now we've got our m, we've got our c. Let's write the equation of the line. Y equals mx plus c. Our final question, guys, a bit more quadratic work to do. This time it's a quadratic inequality, so let's just write it down as it stands. If we don't know what to do with this, just ignore the inequalities and just treat this like a normal quadratic. Let's start solving it. First, try factorising. Two numbers that add to 4 times to -12. That will be +6 and -2. Those two numbers there add to 4, but times to -12. So I'm going to use them to factorise the quadratic. And we get x plus 6, lots of x minus 2, not equal 0, less than or equal to 0. If we were solving this, we'd get the roots, which would be x equals -6 and x equals +2. Now what I'm going to do, I'm not going to stop there. I'm going to sketch the graph of this quadratic. Let me become clear in a second. These things here, -6 and +2, show me where my graph crosses the x-axis. And this is a quadratic, and it's a positive quadratic, so we're going to get this positive U shape. So all I'm going to do is draw this quadratic curve, something like that. That's not a bad effort whatsoever. Now, what we're looking for on this inequality is where is the graph less than or equal to 0. If the equation is less than or equal to 0, I'm looking for where the graph is less than or equal to 0. And more correctly, I'm looking for all the y values that are less than or equal to 0. Where does my graph fall below the 0 line, if you like? This is the part of the graph that I'm interested in, because that's where it's below 0. What I need to do is figure out the x values in that part of the graph. So my x values go from here to here. The x values that I'm interested in are these ones. Any x on that line will kick out a y that is less than or equal to 0. So that's what I just need to capture. What are those x values? Well, x is less than or equal to 2, just coming this way along that line, or greater than or equal to -6, just going that way across the line. I'm literally capturing this number line in a single inequality. If, and it's not the case in this question, let's pretend this inequality symbol was reversed and you had x squared plus 4x minus 12 is greater than or equal to 0. So I've reversed this inequality symbol. Then I'd be interested in these wings here. Where is the graph bigger than 0? And I'd have to say, okay, x is less than or equal to -6, or x is greater than or equal to 2. And I can't write those solutions as a single inequality because it just doesn't exist as a single inequality. We didn't need this yellow stuff. That was just to demonstrate the other version of this question. Guys, good luck with paper 3. Once again, there's no guarantee any of these questions will come up. These are just the skills that haven't been tested yet. There are a handful of other skills as well. Check out my website, check out the most popular topics. You'll see a list that's got what I've covered here and a few bits that I've not covered in any predicted paper. Good luck, keep at it. We got this.